Hi and welcome to week 11. So this is the week 11 of the 30-week countdown from TheMathsTutor.ie for Leaving Cert Ordinary Level Maths. So this week we're going to be looking at complex numbers. So we're going to be looking at complex numbers in this lesson, and we're going to be looking at complex numbers next week as well. So when we're dealing with complex numbers, we're going to be dealing with something a little bit different to anything else we've seen so far, because we're going to be dealing with square roots of -1. So this seems a little bit different. So as always, the 30-week countdown, the full countdown, is available on the TheMathsTutor.ie website for all the full members. And in there, you'll see lots of videos and works examples and stuff. But as always in these lessons, we're going to make a couple of those videos available to everyone. So the first video we have is explaining what we're dealing with the square root of -1. So this video looks at the different type of numbers that we have and how we end up getting the square root of -1. And the second video we're going to see is a video on the complex number system itself. So the two of those videos, they're there in the comments or the chat there, and you should be able to go and look at them after this lesson. So when we're dealing with complex numbers, the first thing is we are dealing with the square root of -1. So you might have used your calculator before and gotten math error or something like that. So if I try and take my calculator and do something like, say, okay, I want to find the square root of -4, and I put that into my calculator is going to say math error. So to help us deal with this, we have a new system of numbers. So we would have seen in some of the other live lessons that we had natural numbers, and we had real numbers, and we had integers, and they had lots of different letters like N and R and Z. And we're going to be dealing with these new set of numbers where we have complex numbers, which allow us to deal with these -1s or square roots of -1s. So we don't have a calculator that we can use to do these, but what we can do is we can split up this square root. So when we have a square root, we can always split it up into square roots of the things that are inside the square root. So what I mean by that is here I've got a -4 under the square root, and that's the same as 4 times -1. So the square root of 4 I'm able to find on my calculator, that's 2. But the square root of -1 I can't find on my calculator. But now we're learning that we're going to have this new system of numbers, and this gives us the letter I. So the letter I is always going to be the square root of -1. So it means that we can take a negative number and find its square root using these complex numbers, which are going to have i's in them. So I can take the square root of -1 to equal I. So I is a number. It's like pi or some other strange numbers like that we come across in maths, but it is always going to be this number. So it's always going to be the square root of -1. And if I take this equation and square both sides of it, I'm going to end up with the square root of -1 squared, which is -1. And on the other side, I'm going to end up with I to be squared, which is I squared. So we'll often see that in questions where they're going to talk about, oh, do this where I squared is equal to -1. So you'll see that that's kind of a clue that we're dealing with our complex numbers and how we're going to deal with them. We also see that oftentimes in maths we use the letter X. So when we don't know something in maths, we're going to say, okay, this is X, and we're going to solve for it. But when we're dealing with complex numbers or these square roots of negative numbers, we'll often use the letter Z instead. So I'll often see Z's coming up in questions, and that's another clue for me that this is going to be something to do with I's and our complex numbers. So that's where we start with our complex numbers. We're going to be dealing with the square root of -1, and we're going to call the square root of -1 I. When we're dealing with a complex number then, a complex number has real parts and these I parts. So we call these I parts imaginary parts. So we're going to have parts that are real and parts that are imaginary. So we have some examples. So for example, I might have a complex number that says 3 + 4i. So this is a complex number because the 3 is real But the I part there tells me that there's also this imaginary number, this square root of -1 that we're going to deal with. This is how we'll often see complex numbers written. And we say this is in the form of a plus bi. So a is the real part, so the 3 in this case, and b is the coefficient of I, so the number that's in front of that letter I. And we can have lots of them that don't necessarily look like they're going to be complex numbers. So if I take something like -7i, that is a complex number because that's the same as 0 minus 7i. So in this case, a is equal to 0. My real part is 0. And my b, my coefficient of the imaginary part, is -7. And it's the same if I take what we would have dealt with before and thought of as only real numbers. So if I take something like 6, that also can be written as a complex number because I can say 6 is the same as 6 plus 0i. And in this case, a, my real part, is 6, and 0, or b, my coefficient of the imaginary part, is going to be 0. And picking out those a's and b's are going to be quite important when we're looking at our complex numbers and how we deal with our complex numbers. So when it comes to dealing with our complex numbers, when I want to do actions with them, when I want to perform actions on them, if I want to add complex numbers, I'm going to add real with real and imaginary with imaginary. And if I want to subtract them, it's the same. Real from real and imaginary from imaginary, we're going to put like with like. If I want to multiply them, we're going to see that that's going to be a little bit different. And then in next week's lesson, we're going to look at how we divide complex numbers. So if I want to do something like adding complex numbers, so this is adding or subtracting complex numbers. We're going to put like with like. So for example, if I take two complex numbers like 2 plus 4i plus 3 minus 6i. So there's two complex numbers. 2 plus 4i is a complex number and 3 minus 6i is another complex number. So we said we often give these the letter z. So one of them would be called z1, my first complex number, and z2, my second complex number. But if I wanted to add these, and I'm putting them in brackets there because sometimes if I'm subtracting them, I have to keep an eye on the signs, making sure that I'm saying a minus by a minus is a plus and things like that. But all we're going to do is put like with like, or real with real, and imaginary with imaginary. So I'll write it out again without the brackets. So 2 plus 4i plus 3i minus 6i. So here it's a plus by a plus and a plus by a minus, so that's fine. And then we're going to put real together. So 2 plus 3, they're both real. So that gives me 5. And then plus 4i minus 6i, they're both imaginary, so they go together. So we're going to say take the small one from the big one, keep the sign the big one, and that gives me minus 2i. So when I put those complex numbers together, I'm going to get another complex number, and I get that complex number by adding real with real and imaginary with imaginary. So where this is going to come to play, and I need to be able to pick out my real and my imaginary parts, is when I'm going to be looking at something called Argand diagrams. So when we come to the papers, the first question that we're going to see here is 2017, paper 1, question 2, and this is going to say on the Argand diagram. Now, an Argand diagram is often looks like your x's and your y's, like your Cartesian plane. So how we would, sorry, just drawing on that by mistake there. So how we would plot our x's and our y's. But because we're dealing with complex numbers, we don't have x's and y's anymore. This time we have a real axis, so you'll see that that's marked RE, and we have an imaginary axis, which is marked IM. So when we have our real and our imaginary, our real part is going to be the part that didn't have an I with it, and our imaginary is going to be the coefficient, the part that's in front of the I. And we said these are often written in the form of A plus BI. So we see here that this question tells me to write it in the form of A plus BI, or it's written in the form of A plus BI, where I squared is equal to minus 1. So that's my little clue here that I'm dealing with my complex numbers where I squared is equal to minus 1. It's reminding me what I is all about here. So this is telling me that this is shown on the Argand diagram, so that's what this is described as, my Argand diagram, and it's asking me to write down the value of A and write down the value of B. So A is going to be my real part, so I'm looking at my real axis here, and B is going to be the coefficient of my imaginary part, and I'm taking that from my imaginary axis. So here's the point Z1, and it's plotted on this Argand diagram for me. So to find the real part, I go up and see, well, what value does that have on the real axis? And I can see that that has a value of 3. So my A is 3. And I'm going to go across then to see, well, what value does it have on the imaginary axis? And when I look at the imaginary axis, B is equal to minus 1. So it only asked me to write down the value of A and the value of B. So I'm saying 3 and minus 1. But if it asked me to write it as a complex number, I'd be saying Z1 is equal to 3 minus 1i, or just 3 minus I. And you see the letter Z there again, because we often use the letter Z when we're dealing with complex numbers. The second part of this question gives me a complex number. So it says Z2 is minus 1 plus 2i, and it asks us to plot Z2 on the Argand diagram. So to do this, we're going to look at this. And again, this is in the form of A plus BI. So we need to pick out what's the real part of this complex number Z2 and what's the imaginary part of this complex number Z2. So the real part here is going to be minus 1 and the imaginary part is going to be 2. So that means that A is minus 1 and B is 2. And we're going to go to the Argand diagram that they've given us in this question, and we're going to go and plot this complex number. So I'm going to go across the real axis until I find minus 1, and then I'm going to go up the imaginary axis until I find the point to the number 2, and I'm going to draw my point on the junction between those two. So between minus 1 on the real and 2 on the imaginary, and then I'm going to label that this is the point Z2. So that's what an Argand diagram is, and we'll see that that question comes up a good bit about reading my Argand diagram, my real and my imaginary, and also plotting points on my Argand diagram. So working out what is real and what is imaginary. So that question from 2017 was just write down what you see on the Argand diagram and plot a point on the Argand diagram. Whereas the 2021 paper 1 question 2 part A, we have to plot things on the Argand diagram, but there's also a little bit of more work here. So this says Z1 is the complex number minus 3 plus 4i, and Z2 is the complex number 4 plus 3i, where I squared is equal to minus 1. So again, that's reminding me what my I is. And I'm being asked to plot and label Z1, Z2, and Z1 plus Z2 on the Argand diagram. Okay, so to plot Z1 and Z2. So Z1 is the complex number minus 3 plus 4i. So when I look at this, I can see in Z1, A is equal to minus 3 and B is equal to 4. So I'm going to go and plot Z1. So I go on the real axis, I go across to minus 3, and then on the imaginary axis, I'm going to go up to 4. So I go across to minus 3 and I go up to 4, and I'm going to draw my dot on the junction between those two, and I'm going to label it that this is the point Z1. Then it asks me to plot Z2. So Z2 is the complex number 4 plus 3i. So with Z2, I'm going to pick out that A is the real part, which is 4, and B is the imaginary part, which is 3. So this time I'm going to go on the real axis across to 4, and the imaginary axis up to 3, and I'm going to draw my dot on the junction between those two. So across to 4 and up to 3, and I'm going to label that that is the point Z2. So that's my second complex number. The third one that it asks me to plot then is Z1 plus Z2. So to do Z1 plus Z2, we're going to have to add together the two complex numbers that they've given us. So that's minus 3 plus 4i. plus 4 plus 3i. And again, I said I'm going to put these in brackets just in case there's a minus in front of the second one. So if there's a minus in front of the second one, I just need to keep an eye on my signs. So just to keep track of, do I need to change pluses to minuses or minuses to pluses? So just to keep an eye on that. But here there's a plus in front, so I don't. So I'm going to write it without my brackets. So minus 3 plus 4i plus 4 plus 3i. And to add our complex numbers, we're going to put real with real and imaginary with imaginary. So we're always putting like with like. So the real parts are the parts that have no i's at all. So minus 3 plus 4, these are both real. So we're going to put those together. So minus 3 plus 4 is 1, and we can do that on the calculator. And then we're going to put the imaginary parts together. So plus 4i plus 3i, they're both imaginary. So when we put those together, like goes with like, we get 7i. So our complex number of z1 plus z2 becomes 1 plus 7i. And now we have to go and plot that on the Argand diagram. So to plot this on the Argand diagram, we go on the real to 1, and then we're going to go up on the imaginary to 7, and we're going to draw our dot on the junction between both of those, and we're going to label it. So to label this, we're labeling this is Z1 plus Z2. So that's using our Argand diagram, so taking an Argand diagram and plotting a point from it, or in the second case there where we had to do something with our complex numbers, and then once we had them plotted, once we had them figured out, we were able to plot them on our Argand diagram. And it's similar in question 2020, paper 1, question 3, part A. So this says Z1 is equal to 3 minus 4i, Z2 is equal to minus 2 plus I, and Z3 is equal to 2i Z2. So Z3 is equal to 2i Z2, where I squared is equal to minus 1. Okay, so in this case here, the first thing that it asks me to do is write Z3 in the form of a plus bi. So it's asking me to write Z3 as a complex number. And it's given me the information that Z3 is equal to 2i times Z2. So I know that this is a multiply because the 2i is touching the Z2. So anytime these things are touching, that always tells me that we're going to be multiplying. So here we're going to be multiplying. So I'm going to say 2i multiplied by Z2. So Z2 is minus 2 plus I. So I'm going to write in that complex number instead of Z2. And now we're going to multiply. So when we're multiplying, anything that's touching the bracket is going to be multiplied by everything that's inside that bracket. And when I'm multiplying complex numbers, I'm allowed to multiply absolutely everything. When I'm adding or subtracting, it's real with real and imaginary with imaginary. But when we're multiplying, we're allowed to multiply absolutely everything. So the first thing I'm going to have to multiply is 2i being multiplied by minus 2. So to do this, we're going to multiply the signs, the real parts, and then the imaginary parts. So we have a plus by a minus gives us a minus. We have a 2 by a 2 gives us a 4, and we have an I, and we have no I inside the bracket, so that gives us minus 4i. And the second thing we're going to multiply is minus 2i by plus I. And again, we're multiplying the signs, we're multiplying the numbers, and we're multiplying the i's if we have them. So the signs, we have a plus by a plus, so that gives us a plus. We have a 2 by a, so we just have an I inside the bracket, so that's the same as 1i. So 2 1s are 2. And then we have an I by an I. So I by I is I squared. So when we multiply out this bracket, so when I multiply 2i by the complex number, I'm going to get minus 4i plus 2i squared. But this isn't in the form of a plus bi. So when I want it in the form of a plus bi, I'm going to have a real part and an imaginary part that just has an I. So what we need to use is the fact that I squared is equal to -1. And we're going to use a substitution. So in this sum that we've worked out, we have an I squared, and we're going to replace that with our -1. So that means that we're going to rewrite this answer, and we're going to say -4i plus 2 times -1. So that's our substitution. Everywhere we have an I squared, we're going to put in a -1 instead. And now we have a multiply, so we'll keep multiplying. -4i plus 2 times -1 is -2. And then we want to write it in the form of a plus bi, so we want the real part first, which is -2. And then we want the imaginary part, which is -4i. So when we multiply z2 by 2i, we end up getting another imaginary number, and that next imaginary number is -2 minus 4i. So the next part of this question then asks us to plot Z1, Z2 and Z3 on the given Argand diagram and to label each point clearly. So again, we have our real and our imaginary axis. So Z1 is the complex number 3 minus 4i. So Z1 is 3 minus 4i, Z2 is -2 plus I, and Z3 we've just worked out is -2 minus 4i. So we need to plot all three of these on our Argand diagram. So again, we're going to see we have our real parts and our imaginary parts. So in Z1, our real part is going to be 3. And our imaginary part, so b, is going to be -4. So I'm going to go across to my real axis to 3 and up on my imaginary axis to -4. We're going to go down on our imaginary axis to -4. And I'm going to draw my dot at the junction between those, and we're going to call that Z1. Z2, we're going to look, the real part is -2. And the imaginary part is the coefficient of I. So here we just have plus I, so that's going to be a 1. So we go across to -2 and we go up to 1. And I'm going to draw my dot at the junction between those and label it Z2. And our last one that we've worked out, Z3, was -2 minus 4i. So A is -2 and B is -4. So we're going to go across to -2 and we're going to go down to -4, and we're going to draw in our dot here on -2 minus 4, and that gives us Z3. So that's how we multiply our complex numbers and then plot those on the Argand diagram. So to continue that then with our multiplying complex numbers, if I have two complex numbers completely to multiply, so if I have something that says Z1 is equal to 3 plus 2i and Z2 is equal to 1 minus 4i, and we want to find Z1 times Z2. So this time we're going to multiply two full complex numbers, not just an I part by a complex number. So what we would have to do here is these two, again, we're going to put our two brackets and we're going to put them touching. So that means that they're being multiplied. And this is a lot like in algebra when you have two brackets touching. So when we have two brackets touching in algebra, we split the first bracket into a 3 and a plus 2i. And both of those things get multiplied by the second bracket, which in this case is a 1 minus 4i. So when we multiply, everything can get multiplied by everything. So 3 ones are 3, plus 3 by minus 4i gives me minus 12i, plus 2i by plus 1 gives me plus 2i, and plus 2i by minus 4i gives me minus 8i squared. And again, like goes with like, so I see that I've got two imaginary parts already. I have minus 12i and plus 2i, so they go together. So we'll say minus 12i plus 2i gives me minus 10i minus 8i squared. But this doesn't look like a complex number. So when I multiply two complex numbers, I should get another complex number in the form of a plus bi. So what we have to do here again is look at this I squared. and replace it with minus 1. So we're going to remind ourselves that I squared is equal to minus 1. So everywhere we have an I squared, we're going to replace it with minus 1. So I'll say 3 minus 10i minus 8 times minus 1 gives me 3 minus 10i plus 8. And now I can see that I have two real parts. So 3 and plus 8 are real, and real goes with real. So I get 11 minus 10i. And that's my answer for Z1 times Z2 is equal to 11 minus 10i. So that's how we multiply our complex numbers, and how we've seen how to add them, and we've seen how to plot them on our Argand diagram. The last thing we're going to look at in today's lesson is this straight lines around a complex number. So when I have these straight lines here, this is something called the modulus. So this is going to be find the modulus of a complex number. And the modulus of a complex number is always a real number. The modulus of a complex number means how far is that complex number from the origin, or what is the distance back to the origin. And there is a formula for this. So the formula for this is the square root of a squared plus b squared. So we've already seen that a was our real part, and we've seen that b was the coefficient of the imaginary part. And when we take those numbers and put them into this formula, we're not putting in any I, so we're going to get a real number out of this. So to do this, we just need to go back up and see what Z1 was. So for this question, Z1 was 3 minus 4i. So Z1 is equal to 3 minus 4i. So we picked out the real part of this was 3, and the imaginary part of this was minus 4. So the b, the coefficient of the imaginary, was minus 4. And we're going to find the modulus of Z1. So this is putting into this formula the square root of a squared, so that's 3 squared, plus the square root of a squared plus b squared. So the square root of 3 squared plus minus 4 squared, which gives me the square root of 9 plus 16, which is the square root of 25, which gives me an answer of 5. So the modulus of Z1, the distance from the origin to the point Z1 on our Argand diagram, is a distance of 5. And that number will always be a real number when we work out the modulus of that complex number. So we'll never have an I in it. So if we looked at our Argand diagram again, what we'd be looking at here is the distance from the origin to that Z1 would be a distance of 5 units. And you could use your distance formula. So you could pick out your A and your B as x1, y1, and your origin as x2, y2. But it's easier just to learn this formula for the modulus, the square root of a squared plus b squared, because we already know what our a and our b are. And when we put them into our formula, we're going to get our modulus of a complex number. Okay, so hopefully our introduction to complex numbers, you got something from this lesson today. Next week's lesson, we're going to continue on with our complex numbers. So we'll be looking in a little bit more detail at dividing complex numbers. So we looked at adding and subtracting today, and we looked at multiplying, and we saw how to plot them on our Argand diagram, and we saw what our modulus meant. And to remember that there's 2 videos there. So the first one is all about what the square root of minus 1 is. So go and check that out. And the second video that we've made available to everyone there is about our complex numbers. So how to use your complex numbers. Okay, so thanks guys.